Hi, you're right. Welcome to your lesson on moments practical. Start off 3 questions. Number 1, what 2 units of distance can moments be measured in? 2, what does a lever do to the force applied to it? And 3, what happens to the moments on either side of a seesaw when the heavier load is moved closer to the pivot? Okay, pause the video to answer those questions now. Okay, so your answers by pen, they can be measured in Newton meters and Newton centimeters. Number 2, it will multiply the force. Number 3, they can become balanced. Okay. So a quick recap of moments. So moment is the turning effect of a force. For an object to be balanced, the sum of the moments has to be the same on each side. So the anti-clockwise and clockwise moments both need to be balanced. A reminder of that formula, which you should have somewhere if you don't, write it down. Moment is equal to the force in newtons times the distance from the pivot in either centimeters or meters. So what we'd normally do in class is we would use this theory and put it into practice by using a pivot, a lever, and some masses. So we would have particular size masses at one end of the lever, then add a lighter or heavier on the other end, change the position of the effort mass on the lever until the system balances. So the object is to get the lever to balance. Record your results in a table, which we'll have a look in a second, using the moments equation. Now, since we are unable to do this in real life in a science lab using this equipment, this type of practical is an easy one that can be done anywhere. All you need is a lever, which could be a piece of wood, a ruler, whatever you've got to hand, as long as it is flat and straight. A pivot, which again can be pretty much anything. You need to make sure it's secured to a point though. You could even use something like a pencil, but it's a good idea to have blue tack or plasticine to hold it in place. And then particular size masses at one end of the lever. So you can use any objects for this. It's most useful if you've got something that you can add more than one of. So if you've got pens that are a similar size, or pencils, or coins, or whatever it might be, in order to try and balance it. So the object is to get both ends of the lever, ruler, whatever it is you're using, to be off the surface and to be balanced. So pause the video now, have a good go at finding something that you could use to complete this investigation. Okay, so this would be your write-up. So what did you do? What did you use? So this will be individual based on what you managed to find for that practical to complete. What results did you get? Now, you might not have the most accurate results because you aren't necessarily using the same size masses each time, unless you use something like coins, which are generally fairly similar. But see if there are any conclusions that you can draw from that. Use these terms: mass, pivot, distance, moment, and equilibrium. So record your answers to these questions, write them down, share them with your teacher, whatever you need to do. Pause the video to do this now. Okay, so we've got a few questions for you to complete. First two on here. So an elephant that's 3,500 kilos and a parrot 150 grams are trying to move a large boulder using a long reinforced lever. What is the total clockwise movement? Key thing for this question is to note down there are a difference in units that you've got. So the elephant's 3,500 kilos, whereas the parrot is 150 grams. So think about what that would mean in terms of the force. Remember, you need to convert that to force going downwards. So 1 kilo is equal to 10 newtons. Remember that. Number 2, mechanic needs to loosen a bolt with the spanner. The mechanic found he could not loosen the bolt with the spanner he had originally chosen. He decided to use a longer spanner and the bolt was easily loosened. Explain why a long spanner made the job easier. Answer those questions now and then we'll go Ben. Okay, so first one, we had to convert the mass into weight first of all. So the weight of elephant is 3,500 kilos times by 10, which is 35,000 newtons. the weight of the parrot. So we had to convert it to kilos first of all, which is 0.15 kilos. Again, times by 10, which is 1.5 newtons. Then we had to work out their moments. So for the elephant, it's 35,000 newtons times 0.1. That's the distance, force times distance, which gives us 3,500 Newton meters. The parrot was 1.5 newtons, and it was 1.5 meters away. So 1.5 times 1.5, which is 2.25 Newton meters. Total amount, we add those together. 3,500 plus 2.25 gives us 3,502.25 Newton meters. For number 2, so increasing the length of the spanner increases the distance of the force from the pivot and therefore produces a larger moment. This means that it will be easier to loosen the bolt. So longer the spanner, the greater the moment. Okay, next 3 questions for you to have a go at. So calculate the clockwise and anti-clockwise moments. Is the system balanced? Remember, you're converting from mass to weight. Calculate, same for the second one. And then the third question, a plank of wood is balanced on a fulcrum. The fulcrum is 0.7 meters from the end of the plank. A box weighing 20 kilos has been placed on the left of the fulcrum, 0.3 meters from the end of the plank. A force of 5 newtons is applied to the other end of the plank. How far from the fulcrum does a force need to be applied for the system to be balanced? Pause the video and answer those questions now. Okay, so to purple pen those for the first one. Remember, mass in kilos times 10 is the force. So the anti-clockwise moment is 500 because it's 50 kilos times 10 times by 4 meters, 2,000 Newton meters. The clockwise moment is 200 times 2 for the first box and 250 times 3 for the second box. So the total moment is 1,150 Newton meters, and that's obviously not the same, so it's unbalanced. For the second question, the anti-clockwise moment, furthest box is 300 newtons times by a distance of 4 meters. Then it's 200 newtons times by a distance of 1.5 meters. That gives us a total of 1,500 Newton meters. On the clockwise side, so we've got 15 kilos, 150 newtons times 2, and 250 newtons times 5 gives us a total of 1,550 Newton meters, and again, that's unbalanced. For the third question, so our anti-clockwise moment, the distance from the box to the pivot is 0.4 meters because it's got 0.7 to the end and 0.3 to the end of the box. And it's 20 kilos, so that's 200 newtons. So 200 times 0.4, the anti-clockwise moment is 80 Newton meters. So if we look on the clockwise side, we know that the moment needs to be 80 Newton meters, and the force that we've got is 5 newtons. So 80 divided by 5 gives us 16. So the force must be 16 meters from the pivot. Okay, that's the end of your lesson on moments practical. Hopefully you managed to do something practical and investigate moments in the real world. And I'll speak to you in the next lesson.